Welcome! In this session, we will introduce artificial neural networks. This session focuses on the first of the three most important types of neural networks that form the basis for most pre-trained models in deep learning, and that is artificial neural networks. Let's try to understand artificial neural networks from the basics. A single perceptron, or neuron, can be imagined as a logistic regression. Artificial neural networks is a group of multiple perceptrons or neurons at each layer. Artificial neural networks is also known as a feed-forward neural network because inputs are processed only in the forward direction. As you can see in the picture, artificial neural network consists of three layers: input, hidden, and output. The input layer accepts the inputs, the hidden layer processes the inputs, and the output layer produces the result. Essentially, each layer tries to learn certain weights. The main advantage of an artificial neural network is that it is capable of learning any nonlinear function. Hence, these networks are popularly known as universal function approximators. Artificial neural networks have the capacity to learn weights that map any input to the output. One of the main reasons behind universal approximation is the activation function. Activation functions introduce nonlinear properties to the network. This helps the network learn any complex relationship between input and output. On the other hand, artificial neural networks have three challenges. Firstly, while solving an image classification problem using artificial neural networks, the first step is to convert a two-dimensional image into a one-dimensional vector prior to training the model. This has a huge drawback. The number of trainable parameters increases drastically with an increase in the size of the image. Another common problem in all these neural networks is the vanishing and exploding gradient. This problem is associated with the backpropagation algorithm. The weights of a neural network are updated through this backpropagation algorithm by finding the gradients. So in the case of a very deep neural network, or a network with a large number of hidden layers, the gradient vanishes or explodes as it propagates backward, which leads to vanishing and exploding gradient. And thirdly, artificial neural networks cannot capture sequential information in the input data, which is required for dealing with sequence data. In the following session, we will see how to overcome the limitations of machine learning using two different architectures, which are recurrent neural networks and convolutional neural networks. Thanks for watching.